Professor Chapuk, do you hear us?
Good afternoon. Can you see me? Can you listen to me?
Yes, we see your presentation, we hear you.
Okay. I would like to share the result of our research on the determination of the minimum anchoring length for a 500 C bar in concrete. This amateur sickle-shaped reinforcement bars manufactured
Sorry,
under the
sorry, we,
store.
we can see a presentation because we see a last page.
Yes, we only see the last slide.
На першу сторінку візьми, а то ти з останньої почав.
It's the second slide.
No,
Yes,
ні.
just show us the slide.
Вибрати було презентацію всього екрана, а не цього PowerPoint, бо це презентує PowerPoint. Можна просто перегортати в PowerPoint.
То зараз бачите ви добре? Першу сторінку.
Ні, ми останню бачимо.
Ага, поняв.
О, тепер перше. Все добре.
Поняв.
Окей.
Thank you. Thank you. These bars are suitable for both non-stressing and pre-stressing applications. Also, there are particular recommendations for calculating reinforcement, anchoring, and there's methodologies require experimental validation. The bond between the reinforcement and the concrete is crucial for the joint performance in reinforced concrete structures. However, experimental studies are scarce on this topic relate explicitly to a 500 C rebar, which complicates the assessment of its anchorage in concrete. This study aims to experimentally determine how the length of rod anchoring affects the ultimate bond strength between the rebar and the concrete, and to establish the minimum required length for rod insertion into the concrete. To investigate the adhesion of stickle-shaped reinforcement to concrete, we prepared samples in the form of concrete prism with a square cross-section measuring 150 millimeters on each side. The height of those prisms was determined based on the accepted anchoring length of the rods, which were 5 diameters, 10 diameters, and 50 diameters. For this study, we selected rods with a diameter of 16 millimeter. The mechanical properties of those rods were determined through tensile testing in a tensile machine following standard procedures. The temporary tensile strength of the rods was sigma 672.2 megapascal. The conditional yield strength was 497.3 megapascal, and the elastic modulus was 12,000 megapascal. The test result demonstrated Definish homogeneity of the concrete in the twin samples. For the sample with anchoring length of 18 millimeters, fracture occurred at an average stress of 135.1 megapascal. In the sample with a light of length of 160 millimeters, a slim value of 0.2 millimeter was observed at average rod stress of 248.8 megapascal, while for the sample with 250 millimeters light length, the average stress was 398 megapascal. As the anchorage length increased, the stresses in the rods also increased, indicating that slippage in the concrete began to be observed, as well as the stress corresponding of the adhesion limit state. It is noteworthy that all priests after reaching delta 0.2 millimeter under increasing load experiential brittle failure characterized by splitting along the road. In samples with shorter and anchoring length, cracks initiated from contact with the bottom plate of the press, while in this with longer anchoring length, crashing began from the free end of the prism. Therefore, a slim value of the free end of the rod in concrete equal to 0.2 millimeter can be considered a criteria for determination of adhesion limit state of sickle shaped reinforcement or to concrete. According to the test results, average values of the maximus tangential adhesion stresses were calculated for each group of samples, assuming the values were constant along the length of the rod passed of the following Formula 1. The analysis of experimental studies indicate that the stresses in the rod at the adhesion limit states 0.2 millimeters depend linearly of the anchoring length and can be expressed by the barrel formula 2. The standard tensile strength for 500C class reinforcement is 500 megapascal, while the calculated tensile strength is 400 megapascal, based on Formula 2 to ensure equal strength in terms of cohesion between the roads and C/25 class concrete. A minimum anchoring length of at least 303 millimeters is required to achieve the design resistance in the reinforcement. The minimum length should be 242 millimeters, which corresponds to at least 20 times the diameter. Their findings have been supported by both preliminary and main experiments. It is important to note that the coefficient K should be different to each class of conference. The tangential adhesion stresses is in sample with anchoring length of 80 millimeters, 160 millimeters, and 250 millimeters were calculated using Formula 1 as following. Tau is 6.7, 6.2, and 6.6 megapascal, with corresponding stress values in the bars as sigma 135.1, 248.8, and 398 megapascal, respectively. This result indicates that the tangential adhesion stresses in the limit state are largely independent of the rod anchoring length. In conclusion, we can draw the following main points. The limit state of adhesion between sickle-shaped reinforcement and concrete is defined as the condition where the displacement of the free end of the rod relevant of the concrete reached 0.2 millimeters. Experimental evidence suggests that the minimum length of anchoring the rods should be no less than 15 diameters in a section designed to achieve complete resistance. And the stresses in the bars at the adhesion limit stage are linearly dependent on the anchoring length and can be calculated using the empirical formula to